Okay, we're at the top of the hour, so let's get started. Welcome to GitLab Demo Days series. We're in session number 5, talking about Open DevOps Platform. Today, I'll be giving an overview about this platform, some housekeeping rules. If you have any questions, please enter them in the Q&A box on the bottom. I'll be answering questions at the end of the presentation, but please write them down so we don't forget them along the way. Let's get started. So my name is Arika Lewinsky, and I'm a group product manager here at GitLab for the Managed stage. Again, I want to welcome you to GitLab Connect. I'll be your designated presenter for this session. Again, I'd like to hear any questions you have, and we'll be talking about the DevOps platform, the single application of the DevOps platform. We'll be talking about DevOps metrics, and we'll be talking about DevOps reports. And again, we'll have the Q&A session at the end. So I'm going to start with showing you this very familiar diagram that we have on the GitLab handbook, which talks about the DevOps concepts. The DevOps concept separated the software development lifecycle into different stages, creating a continuous process for repetitive development and deployment tasks. DevOps means adjusting your business to meet growing challenges such as scaling for load, or cost, efficiency, and ensuring high availability and designing for failure. Adopting DevOps means solving those challenges by increased value-driven deployments, reduced complexity, and increased automation. In GitLab, we have a single application that kind of covers all of your different DevOps stages mentioned here in this slide. And what I wanted to talk about is the GitLab DevOps platform benefits. So as a single application for the complete DevOps lifecycle, GitLab is both comprehensive. You can visualize and optimize your entire DevOps lifecycle with platform-wide analytics, which we'll be talking about in this presentation, within the same system where you actually do your work. It's seamless. You can use a common set of tools across teams and lifecycle stages without dependencies on third-party plugins or applications or APIs that can disrupt your workflow. It's secure. You can scan for vulnerabilities and compliance violations with each and every single one of your commits. It's transparent and compliant, which means that you can automatically capture and correlate all actions from planning to code changes to approvals for easy traceability during audits and retrospectives. And lastly, it's easy to adopt. You can learn a single user interface, you can manage a single data store, and you can run it on any choice of different infrastructure that you would like to store your GitLab instance on. I would like to recap on the DevOps principles a bit before we move on. So DevOps is a somewhat abstract concept that focuses on a few key principles. Speed, so the application, the development process, the release capabilities, they need to remain extremely fast in order to better adapt to customer needs, changes in the market, and new business goals. DevOps attempts to keep things moving along rapidly so companies can maintain the constant pressure that's necessary for modern development, including rapid releases. Practices like continuous delivery and continuous integration make it possible to keep that speed up throughout the development and operation stages of our project, which are key to the DevOps lifecycle. Reliability, continuous integration and continuous delivery techniques also improve the overall stability and reliability of the software as a platform. They ensure that the user experience is optimal, which allows also the teams to rest easy knowing that the application is robust and you can stop at any stage throughout the software development lifecycle. Integrating automated testing suites and powerful execution handling software help the teams identify problems immediately. They rely on rapid feedback, and they can be alerted if there's any unforeseen issues, and they can take action on it immediately. Rapid delivery, which is something that we already mentioned. DevOps aims to increase the pace and the frequency of new releases, allowing the teams to improve the software as often as they can. Performing frequent phase-based releases ensures that the turnaround time on any given bug, fix, or new feature is as short as possible, and this provides the maximum benefit to the users. CI and CD are paramount for meeting the rapid delivery needs of most DevOps models. Collaboration. DevOps strongly encourages collaboration throughout the entire development lifecycle. Every team member is encouraged to take ownership and is accountable for aspects of the project which he or she are involved in. This leads to more effective and productive teams, reduces mistakes, and it even improves job satisfaction. Both system administrators and developers collaborate throughout the project by sharing responsibilities and workflows. Collaboration also extends beyond the organization. Improved collaboration also includes users, which are our customers, our clients, maybe third-party partners, and so on, and encourages the team to work closely with users throughout the development lifecycle, producing a more polished final product, and also involves them early on in the stages to get their feedback. This dramatically reduces the time and money that might be wasted by rerouting production features based on user feedback. Security. DevOps encourages strong security practices by automating compliance policies, simplifying configuration processes, and introducing detailed security controls as part of the development itself. Infrastructure as a code practices improve security by largely removing the human elements when provisioning new hardware and services. Since additional scaling would largely automated and handled by code APIs within the cloud. Creating new infrastructure that matches existing configuration is a breeze and far less error prone. Beyond that, practice of policy as a code is a similar concept in which security policies and compliance can be configured, executed, and monitored via cloud-based APIs, which ensures that the resources that fall out of compliance are immediately noticed and can be evaluated by the team in order to get them back into compliance as quickly as possible. Security should not be thought about as an add-on. It's a must-have design feature. Blending security and DevOps would not only enhance the impact of DevOps, but also eliminate a lot of other bottlenecks that could arise otherwise. With the rise in frequency of cyber threats and tightening the regulations, adding security to DevOps is not a choice. It's certainly an obligation by now. And the last of the DevOps goals is scalability. DevOps also heavily focuses on creating applications and infrastructure platforms that scale quickly and easily with the ever-changing demands of the users and the business needs. Ideally, such a scaling process would be automated and reliable, giving software the ability to adapt on the fly when a sudden marketing effort goes viral or a cool new feature is released. Practices like infrastructure as a code are becoming popular, which emphasizes the importance of provisioning and managing infrastructure components using code and sorry, my microphone just switched, so let me make sure that you can hear me. Can you hear me? Can you give me a sign that you can hear me?
Yes, yes.
Okay, great. So my microphone's changed, so I apologize for that. What I wanted to say was that implementing these scaling practices, DevOps aims to improve the creation of all deployment, testing, staging, and production environments, and makes the process efficient and repetitive. Okay, so we talked about DevOps, we talked about the DevOps goals. What I wanted to talk about today about the DevOps platform is that business survival depends on a radically faster DevOps lifecycle. Mark Anderson said that every company is now a technology company. He coined the phrase, software is eating the world. He also said cycle time compression may be the most underestimated force in determining winners and losers in tech. We've heard all these quotes before, and so there's no doubt that the future of business is software. With unprecedented speed and vigor, the digital era of business has arrived. Every executive leader knows software is powering their business and has become the new face of the company. Competitiveness depends on how fast teams can deliver code, which is in turn translated into customer value. As the world moves into software, competitiveness hinges upon the business's ability to development and deliver software faster. Increasingly, businesses will be won or lost based on their IT ability to deliver great software at new speed and being compliant. So Even having said that, today's toolchain limits a faster DevOps lifecycle. The reason is that even though we have a full transformational promise of DevOps, it's not being realized because of the very tool change that we're using in order to try to accelerate. In fact, today's tool chain is limiting a faster DevOps lifecycle. Some numbers are always great to talk about. So despite $3.9 billion having been spent on DevOps software last year, more than half of the time spent on DevOps is wasted on logistics and repeatable tasks. Although some aspects of the lifecycle have already been moved to automated processes instead of manuals, it's not moving the dial. In fact, almost 90% of the organizations that have already adopted DevOps are disappointed with the results, according to the 2017 Gartner report. While improvements have been made for specific KPIs like deployment frequency and change failure rate, which we'll talk about later on in this presentation, ultimately the full transformation promise of DevOps has not yet been realized. And even though we've implemented DevOps, it's not working how we expected it to be. And why is that? The reason is there's a multitude of different tools out there. You can see here the core stages of the DevOps lifecycle with different tools that you maybe are using in your own tool set. And you may have a planning tool and a code creation tool and all the way to the monitoring tool. And these are just some of the tools that can potentially be used in each one of the stages. Some teams use different tools for the same stage, and they all have to integrate together. This chaining together of tools comes at a cost of integration, complexity, onboarding, and a lot of different challenges. You need to have resources to design, build, and maintain the integrations, manage the upgrades, establish high availability and disaster recovery for each one, manage the different administration of users, permissions, and so on. And they are brittle and they can fail. Setting up a new project or troubleshooting and optimizing an existing project becomes really difficult and is slow for today's demands. The tool chain only serves to reinforce silos that you're already trying to break down in the name of DevOps, but instead of teams being able to collaborate together, they're using different tools and they put them in different workspaces, and this makes collaboration even more complicated. The tool chain and the silos that it creates, the tool chain and the silos that are created create three main problems. One of them is that it's opaque. Because your data lives in multiple data stores across multiple tools, you can't introspect it. The different silos between the teams and their tool market makes it really, really hard to understand the whole picture instead of the individual pieces of the puzzle. It's extremely hard to gain an overall visibility of where the issues lie that need to be solved or where your bottlenecks are. In order to see what's going on or to measure and track progress, you need to build yet another set of tooling on top of your tool chain, which leads to even more integration complexity. The second problem is that the tool chain is inefficient. Individual silos also means that teams still rely on manual or semi-automated or maybe even automated handoffs, but one team can't start the work until the previous team has finished theirs. So we've added DevOps, but the workflow is still very much sequential. And the last problem is that the process is simply uncontrolled. Because different tools have different permissions and security policies, you lack control over your total environment. It's very difficult to establish trust. In addition, shipping secure and compliant software is difficult because security is an afterthought. It's not part of the process. It's difficult to enforce security in every single tool. And in fact, your security team is probably using yet another tool to accomplish this. So GitLab enables concurrent DevOps by providing a single application for the entire lifecycle, which accelerates the development and delivery by 3 times, and in some cases, which have been reported by almost 30 times. You can see our different stages, which is basically just laying down that DevOps infinite loop cycle. We have manage, plan, create, verify, package, secure, release, configure, monitor, and protect. A single conversion, single data store, single permission model, single interface, built-in governance and security, team collaboration, and lifecycle analytics. So many customers choose to adopt GitLab in a gradual process, starting with a use case where they feel the greatest pain. Typically, they start with either source code management or continuous integration. Sometimes they'll start with agile and project management, but most often it'll be source code management or continuous integration. Then over time, they adopt more capabilities in GitLab, including security and continuous delivery. The common theme that we've been hearing from customers is that they adopt more breadth of GitLab capabilities, the more they uncover greater and greater value. Having the developer delivery workflow in a single application like GitLab means that teams are able to collaborate and partner to increase delivery velocity and reduce friction. They are faster and have less overhead because they're all in one solution. I think it's important to ensure that you appreciate and understand the value that GitLab can bring, not only as a point solution, but also as a solution for your end-to-end software delivery lifecycle. So there's only one interface that the developers need to learn. It's one place to manage and control access, one place to track and audit compliance, one place to automate pipelines and ensure quality and security, one place to manage and orchestrate deployments to production, one place to plan and manage the product backlog, one place to prioritize business goals and epics, and then track them all the way to the delivery. GitLab covers all the bases in a single application and streamlines your application delivery practices and processes. So GitLab allows a wide variety of branching strategies and workflows. And because of this, many organizations end up with workflows that are not too complicated, not clearly defined, or not integrated with issue tracking systems. Therefore, we propose GitLab Flow as a clearly defined set of best practices. It combines feature-driven development and feature branches with issue tracking. The GitLab Flow is a clearly defined set of best practices, a simplified branching strategy. All features and fixes go into master, allows for production or stable branches. Bug fixes or hot fixes are cherry-picked from master. We recommend for DevOps teams to follow the GitLab Flow process while using GitLab capabilities within a concurrent development lifecycle. The GitLab application is based around a feature branch-based workflow, the merge request, which can be thought of as the core of the product. The gray line below here on the slide shows the master branch. Notice that another gray line breaks off the master branch and eventually ties back into master. That's what is known as a feature branch. The feature branch represents the source code pattern where a developer opens the branch and begins to work on a new feature. And that work is soon integrated into the master branch. We begin by creating a discrete unit of work by creating an issue or a ticket. We assign the issue to a team member. From the issue, we spawn a feature branch, which can be thought about as a parallel line of development. Developers move to the branch to interact with the request. GitLab provides updates and notification on the state of the issue automatically. And if you work with a feature branch for more than a few hours, it's best practice to share the results with your immediate team. It may not be ready to be merged, but feedback is welcomed. Your team can make comments on the merge request in general or on specific lines. The merge request serves as a code review tool, and no separate tool needs to be integrated in there. When you're comfortable with your work and the comments made, you can assign it to someone who knows about the code base, can perform a code review, resolve any conflicts that may rise, and the commit kicks off to an automated continuous integration pipeline that runs and goes through each steps of the right of the slide. The advantage is that the developers have visibility into what's going on into the cycle. We even have review apps that let you spin off a dynamic environment that's like a production environment and lets you see what your fix and your code looks like as if it was in production. This is a common workflow example. I'll just skim through this. You create and discuss a new issue. You then create the code that is connected to the issue. You create code commits and a merge request, and you deploy to staging. You see that everything's okay. Once it's ready, you can then run and deploy into production. So we've talked a lot about the single application and what GitLab looks like in terms of the single application and what benefits you have from working with the single application. which is mainly reduced cost, auditability, improved toolchain security, speed of innovation, improved compliance, continuous improvement, visibility and analytics, seamless collaboration, and developer experience. The next part of the presentation, I want to talk about continuous improvement, visibility, and analytics. So the main question that I would like to ask is DevOps ROI even a valid question? Measuring the value of a change in process is always going to be more difficult than measuring the ROI of, say, buying a piece of equipment or launching a new product, because there's no dollar signs attached to our process. But without measurements, there really is no clear way to know if an organization is improving over time or if their DevOps investment are even worthwhile. So I'm going to present several different metrics that are known and less known in the industry, and what we can show in terms of what GitLab supports today and what it will support in the future. So as I mentioned, ROI for DevOps is a bit tricky because it's hard to put a price tag on a process that's not a commodity. DevOps requires a huge investment in every single organization, and executives really want to know what they're getting in return. So the first metrics that I want to talk about are DORA4. DORA4 are the DevOps research and assessment metrics that were established in 2019 as a benchmark to identify elite performance, productivity, and scaling. The metrics that were defined are used to measure velocity and scalability. So these are the 4 metrics that form the DORA4. We have deployment frequency, which basically tells you how often your organization deploys code to production or releases it to the end users. Lead time for changes, how long it takes from code committed to go to code successfully running in production. Time to restore, how long does it take to generally restore service when a service incident or a defect that impacts users occurs? For example, an unplanned outage. And change failure rate, what percentage of changes in production or release to users result in degraded services and require some kind of remediation? For example, a hot fix or maybe a rollback. The reason all these metrics are specifically related to production is because it tells you how often you're delivering something of value to your end users and not necessarily just a feature to a development branch, and how you're getting feedback from those users. These metrics are here to tell you de facto how your organization is doing based on a benchmark assessment. Some organizations even use these metrics internally as a way to give more responsibility and freedom to high-performing teams where they can get their wings, which means that they are allowed or not allowed to do certain activities like deploying directly to production based on their DORA4 performance. So the GitLab take on the DORA metrics are as follows. The definitions are very generic, and so it's really important to understand how they are defined. In the classic definition is how often an organization successfully releases to production. In GitLab, we're also doing a very similar measurement. We're doing the average deployment frequency to production at the specified granularity over the given date range. So you can set a timestamp or say, I want to know my deployment frequency for the last week or month or 90 days and so on. Lead time for changes is the amount of time it takes for a commit to get into production. Our GitLab take on it was the median time it takes for a merge request to get merged into production, and I'll show you what that means in the slide where I show that what the chart exactly looks like. A change failure rate, the percentage of deployments causing a failure in production, which we defined as the incident count divided by the deployment count. So how many incidents divided by how many deployments there were. And the time to restore is how long it takes our organization to recover from a failure in production, which we're calculating as the average duration from open to close of all incidents opened in the time period. We started by defining all these metrics for people using the entire lifecycle in GitLab, so everything integrated, but we are also open to playing well with others. If you do decide to use other tools inside your development process, we're also exploring other ways to measure these two besides relying on incidents. So what this actually looks like in GitLab is as follows. Everything is supported both on the two metrics that I'm going to show you now are supported both on the API level and in the UI, similar to this chart that I'm showing you now, and are supported both for the project level and for the group level. So you can see this on a single project, you can see this on a group of projects. So what you can see here is the deployment frequency of GitLab. This is actually a real snapshot that I took in April of our deployment on GitLab.org. So this is a real chart, not simulated. And what you can see here is all the different deployments that happen to production. The timestamp can be changed. You can see on the top, there's a new tab for deployments. That's the first metric that we show. Sorry about that. The next one is lead time for changes. So lead time for changes is this metric here. You can also see this is live from GitLab.org. It's a real chart that has been seen. And what you can see here is that we took the median. The reason we took median for lead time for changes is that we're measuring how many merge requests actually hit production. And what we noticed when we built this chart was that during the weekend, no merge requests hit production. And so it would drop and the average would be a little bit messed up because that's the way average is calculated. So what we did here was we're calculating the median, and you can see the lines where no actual deployment happened. You can see that we're kind of visualizing that inside the graph. So that's our DORA4 efforts. We still need to add the two remaining metrics, mean time to merge and time to restore. So those are coming up. Now I wanted to talk about two different types of metrics that can be visualized in GitLab. The first one is value stream analytics. And what value stream analytics comes to answer is how quickly our teams delivering end user value and give you end-to-end visibility. So you really get insights into the entire flow. Because GitLab is an end-to-end platform, it's uniquely positioned to provide insights into the entire time it takes to deliver value to end users. From ideation, from the minute that you open an issue, all the way till you're monitoring it into production. So it really gives you that great value that you get from a single application. You could probably get this by integrating different teams and creating yet another tool that can pull this information from different tools. But in GitLab, you have everything baked into the single tool, and that really gives you that great value. So what this looks like is you can use our default value stream stages, what we call it, or you can create your own stages that map into your individual deployment development flow. You can see that here, the way to create a new value stream. They're comprised of different stages that represent your development flow. And again, as I mentioned, you can customize them. And they're defined by a start and end events that indicated when a work moves basically from one column to another, from ready to be taken to done, or from an issue until it's actually coded and when it reaches production and so on. Our next step is to evaluate. So we want to review the stage times for the custom value stream and understand which stage is taking the most time. So you can see here, there's different timestamps that tell you how long each stage is taking. It shows the median time that workflow item has been for a selected date range and how long it's spent in that stage. And in the future, we plan to support average time as well as median. And the overview stage shows the sum of each one of that stages in the value stream. A great benefit that we get here is that you can troubleshoot or find the bottlenecks and find the items that are taking the longest and drill down to figure out what caused the delay. Since GitLab is the source of the data, your really single source of truth for the entire software development flow, not only can you get an overview of speed and reliability, you can also drill down into finding the underlying reasons for delays. So you can really go in and understand the issue list, see which one specifically took too long, and drill down and find and learn from that and retrospect what can go better next time. Okay, so we can iterate, we can compare, we can adjust, and we can measure. So we can fine-tune development processes this month and measure the impact on stages by comparing the stages for different periods. So let's say I identified in the previous slide a problem and I addressed it. I can now go to the next month, change the process, and measure how that is changing over time. And if that little adjustment worked to my advantage, whether I should keep it, whether I shouldn't. So it gives you a lot of control over your process and gives you visibility into looking into the past and also measuring it in the future to see that your changes were indeed made the process faster. So we talked about the fact that DevOps is a huge investment in every organization. And what interests the executives is, how am I getting my ROI? This really lets you analyze how you're investing your time. And you can see that this chart shows us how our different developers are investing their time. Are they working on bugs? Are they working on direction items? Are they working on tech debt and so on? So you can customize by creating your own label and figuring out really what interests you and see if the time adjusted needs to be changed. This is what we plan value stream to look like at the end of the day. You can easily identify trends in individual stage times and overall speed and delivery. You can set goals for improvements and track against goals. You can find areas for idle or block time to better understand how to speed up delivery, and view current and historical DORA4 metrics, which can also show how a reduction in stage items impact DORA metrics. So you can see here, the different items per stage. You can really see the distribution in one place. You can easily link into the different drill down metrics and so on, and see the trend lines and so on, filter and sort it, and really make this super easy and friendly to use and make it really valuable for any team looking for insights on how to improve in their DevOps journey. We also have a concept of DevOps reports. This is available also on GitLab.com today. This evaluates your DevOps maturity. You can get insights into which DevOps practices your teams have already adapted and which actually need to be adopted. You can sort by different features like security scanning and find all the teams that either have or have not adopted specific features that you require. This is especially important for security and compliance. If there's a policy in your organization that teams need to follow a specific process, you can monitor and see that everyone is now actively using security scans as part of their pipelines or have added unit tests and so on. In the future, what we would like DevOps reports to look like is have this consolidated view, as you can see here, where you have a DevOps score based on benchmarks to similar organizations to you that we have on GitLab.com, obviously anonymized data, but it'll tell you where you're placed versus similar organizations in the field, in the industry. You can see the different stages. Here we're using our GitLab stages, verify, package, release, configure, monitor. You can see what key features have been already adopted, and you can see which have not, and really take action and decide, should my teams be using this process? Should they not? It gives you really nice control over it. So you'll be able to sort by DORA4 metrics, finding the highest performing teams and see what tooling and DevOps practices contributed to their success. So you can copy and paste that into additional teams. Maybe even make them the mentors for additional teams. Find lower performing teams and identify processes that can help them lift their performance. See trends in the GitLab adoption over time. You can check progress and migration from other tools, and you can check progress on initiative to follow specific DevOps practices like merge request approvals, maybe approval to production deployments, and so on. What I do want to also discuss some alternative metrics that we currently don't have in GitLab, but they're definitely food for thought when you're talking about ROI and metrics for DevOps. One of them is time is money, which isn't new, but DevOps enables us much more and faster code deployments, which means a decreased time to market and more opportunities to capture revenue for customers. So this really does translate into money, and you can check that over time. Financially, measuring quality improvements, it calculates ROI from a cost avoidance standpoint. So unlike which ROI am I getting into the company, it considered the increased quality of work performed under a DevOps framework, which increases customer satisfaction and reduces customer abandonment. So we can actually use retention, customer retention, as a metric for our successful DevOps adoption. And enhance productivity. So a calculation of idle time and how it's avoided is a really great way also to put dollar signs on our DevOps adoption, because the easy way to measure this is by looking at the number of deployments per day per developer. So they're all designed to show throughput and stability in the development process. The ROI of anything requires a long-term analysis, so it's not just something that you can look after 1 month and then be done with it. It involves looking at more than one factor at a time. And this kind of multivariable analysis means that analyzing financial impact of DevOps across a spectrum of accounting line items by measuring, for example, the amount of time saved over a year in categories like change deployment, automation of repetitive tests, and support, and then multiplying those numbers by the average cost of an hour of the developer's time is hard ROI in annual dollars saved that can be calculated and can also be used as very good metrics to check your DevOps adoption. So thank you, and I'll be taking questions now. Do we have any questions in the Q&A box? Doesn't look like it. Does anyone want to raise their hands and ask any questions now? Okay. So I'd like to invite you to join our next demo day session, which is going to happen Thursday, 1st of July at 11 to 12. It's going to be a deep dive in the open DevOps platform, which is a deep dive into what we discussed today. And if you have any questions, please ping me at Ogolowinski on GitLab or Twitter. My Twitter handler is go_Orit.